Going back to last week, we had a power triangle where this was S in VA, this is power in watts, and this is apparent power Q in VARs, volt amps reactive. Remember that, yeah? So we've got a real part, an imaginary part, J, yeah, and a complex number containing both terms, S, yep, in VA. So, for part D, the power in the resistor, because the resistor has no reactive part to it, current and voltage is in phase, we can simply do IR times V. That is the 8 amps times 400 equals 3,200 watts. Yep. Okay, because it's resistive only, so it isn't complex. And actually we could equally say that that is VA, and we could say that was S, really. If we give it that complex quantity, but it's got no angle associated with it, because that's just a resistor. Does everybody understand that bit? And then if we move on to E, what we're doing is we're finding S for the inductor. We can get that from the inductor current times the voltage. Okay? What was the inductor current? 38. I'm going to take the answers from 38.3. Was it not? Amps, angle, minus 18 degrees. That's from the answer from
the inductor. Is it up 30.8?
30.8. You're looking in the wrong place on a piece of paper, Richard. 30.8 angle minus 22.6 multiplied by 400 angle nothing. The result of which is, if you just do that for me, because I've done it in a slightly different way on here. Yeah. 1, 2, 3, 2, 0, angle minus 22.6 degrees. No. And that is, people, that is VA right? How can we get the power out of that? If you convert that to rectangular form, okay, on my piece of paper, that is, you can check 1360 watts minus 4720 var. The J part as in VARs. So here we got power, and here we got not apparent power, Michael, reactive power. Getting late. Reactive power Q, power P in watts, and that's in VAR. So that's how you can get those individual components out of a value for S. See that now? And yeah? And then the total complex power can be found by the total current and the voltage, or adding the two individual complex powers together, whichever is your choice. All right?